Hello students! Welcome to Math&Magic. For today's video, we will talk about the different theorems associated with tangent lines and circles. This includes radius tangent theorem, converse of radius tangent theorem, two tangents external point theorem, and tangent circles internally and externally theorems. Now, if you are new to this channel, I recommend watching these videos about introduction to circles and theorems about radius, chords, and arcs. This will serve as primer to the theorems that I will discuss for today. Moreover, please take note that proofs of the theorems are not included. It will be uploaded in a separate video. To start with, a line is said to be tangent to a circle if it touches the circle at exactly one point. The word tangent came from the Latin word tangere, which means to touch. This simple concept forms a lot of different relationships to some parts of a circle. This involves the aforementioned theorems. Now for radius tangent theorem, it states that if a line is tangent to a circle, then it is perpendicular to the radius at the point of tangency. This theorem implies that the angle formed by the intersection of radius and the tangent line is 90 degrees or a right angle. In the figure, line BC is tangent to circle A at point D, and segment AD is a radius of the circle. Therefore, segment AD is perpendicular to segment BC at point D. As an example, in circle T, line AB is tangent to the circle at point S. Find the measure of angle SBT if the measure of angle STB is 48 degrees. For this item, since radius TS is perpendicular to tangent AB at point S, as stated in the theorem, then the measure of angle TSB is 90 degrees. By joining points T and B, we form the right triangle TSB. Recall that the sum of the interior angles of a triangle is 180 degrees. Hence, we can say that the measure of angle STB plus measure of angle TSB plus the measure of angle SBT is equal to 180 degrees. Substituting the values, it will be 48 degrees plus 90 degrees plus the measure of angle SBT equals 180 degrees. 48 plus 90, the sum is equal to 138. Transposing that value to the right side, it will be negative 138. Now 180 degrees minus 138 degrees, the difference is 42 degrees. Hence, the measure of angle SBT is 42 degrees. For the converse of the previously mentioned theorem, if a line is perpendicular to a radius at its point of tangency on the circle, then it is tangent to the circle. As an example, in circle T, line AB is tangent to the circle at point S. If the radius is 4 meters and segment SB is 3 meters, what is the length of segment TB? Just like in the first example, we need to establish the relationship between radius and tangent line. And as stated in the theorem, the lines are perpendicular and thus form the right triangle TSB. In the example, we are looking for the value of a side of a triangle, given the other measures in a right triangle. Hence, we consider using the Pythagorean Theorem in solving the length of the remaining side. Equation will be the square of segment TS plus the square of segment SB equals the square of segment TB. Substituting the values, segment TS is 4 meters, while segment SB is 3 meters. The square of 4 is 16, while the square of 3 is 9. Adding 16 and 9, The sum is 25. Solving for the length of segment TB, we will get the square root of both sides. Hence, segment TB is 5 meters. Now moving to the third theorem, the two tangents external point theorem. It states that if two tangents are drawn to a circle from an external point, then we consider the following. First, tangent segments are congruent, and second, the line joining the external point and the center of the circle bisects the angle formed by the two tangents. In the theorem, there are 2 points to remember. Number 1 is that the segments that are tangent to the circle have the same lengths. And number 2 is that the line which connects the center and the exterior point divides the angle formed by the tangent lines into half. Also take note that this theorem may use some familiar concepts in geometry like right triangles, use of Pythagorean Theorem, and angle bisector. As an example, in the figure, lines HT and HW are tangent segments to circle O from the external point H. Now, if radius OT is equal to 8 units and segment HT is 15 units, determine the lengths of segments OW, HW, and OH. For this item, let's try to establish some relationships to the parts of the circle. Notice that OT and OW are radii of circle O. Thus, the measurements of radii are the same. If OT is 8 units, then radius OW is also 8 units. Now for segment HW, as mentioned in the theorem, the length of segments formed from an external point of a circle are congruent. This means that if HT is 15 units long, then segment HW is also 15 units in length. Lastly, for the length of OH, since triangle OTH is a right triangle, remember that in radius tangent theorem, the angle formed by a tangent line and radius is 90 degrees. That implies that angle OTH is a right angle. So OTH is really a right triangle. From here, we can now use Pythagorean Theorem to solve for the missing length. Formula will be the square of segment OH equals the square of segment OT plus the square of segment HT. Now substituting the values, segment OT is 8 units while segment HT is 15 units. The square of 8 is 64. The square of 15 is 225. Adding 64 and 225, the sum is equal to 289. Solving for segment OH, we will get the square root of both sides. Hence, segment OH is equal to 17 units. Now, as you have noticed, this concept provides the possibility of having a figure enclosed through its tangents. Such figures are called circumscribed polygons. To better understand this, let us consider this example. In the figure, Rn, Rs, and Ns are tangent segments of circle C at points T, X, and W of the circle respectively. If segment RT is 9 cm, segment NT is 4 cm, and segment SX is 7 cm, what is the perimeter of triangle RNS? In order for us to find the perimeter of the triangle, we have to measure the lengths of the sides Rn, Rs, and Ns. Also, as stated in the theorem, tangent segments are congruent. This means that the measure of RT is the same as the measure of Rx, measure of NT is the same as NW, and SX is the same as SW. Thus, Rn equals RT plus NT or 9 cm plus 4 cm which is equal to 13 cm. For RS, that is equal to RX plus SX, or 9 centimeters plus 7 centimeters, which is equal to 16 centimeters. And lastly, for NS, that is equal to NW plus SW, or 4 centimeters plus 7 centimeters, or equal to 11 centimeters. Therefore, the perimeter is 13 centimeters plus 16 centimeters plus 11 centimeters, or 40 centimeters. For the last theorem, this specific theorem is formed when circles intersect each other at one point. Such circles are called tangent circles. And there are two possibilities for circles to be tangent to each other. Internally tangent, just like this one, and externally tangent as shown in this illustration. Now this theorem states that if two circles are tangent internally or externally, then their lines of center pass through their point of tangency. To concretize your understanding of the concept, let's try to answer this example. In the figure, the radius of circle O is 2 units and the radius of circle C is 11 units. If segment XY is a common external tangent and measures 12, what is the length of segment CO? To answer this problem, we need to supply additional information for it to be easily solved. Here we will identify a point along segment CX, say point M, such that segment MX has the same distance as segment OY. Now given segment OY is 2 units and segment CX 11 units, then we can say that segment CM is 9 units. That is 11 units minus 2 units. Likewise, since we are able to form a rectangle, segment XY is congruent to segment MO. Thus, it is also 12 units. Now that we have sufficient information, we can now solve the length of segment CO using Pythagorean Theorem. Equation will be the square of segment CO equals the square of segment CM plus the square of segment MO. Substituting the values, segment CM is 9 units while segment MO is 12 units. Square of 9 is 81. Square of 12 is 144. Adding 81 and 144, the sum is equal to 225. Getting the square root of both sides, segment CO is 15 units in length. For our last example, in the figure, segment KB is a common tangent of circle O and circle C at points L and B respectively. If segment KB is 24 centimeters, segment KL is 9 centimeters, and segment CB is 8 centimeters, find the length of segment OL. Now when dealing with this kind of item, it is suggested to use the concept of triangle similarities. The similarity suggests using the proportionality of the parts of the smaller right triangle KLO in relation to the larger right triangle KBC. By proportion, we can say that segment KB over segment CB is equal to segment KL over segment OL. Now substituting the values, it will be 24 over 8 equals 9 over segment OL. By cross multiplication, it will be 24 times segment OL equals 9 times 8 or 72. Dividing both sides by 24, segment OL is equal to 3 centimeters. Thank you for watching. God bless.